is Malaika, and I am a sophomore nursing student at Temple University. I'm so excited for GETT's new video series. My favorite GETT memory is definitely visiting each of the booths, meeting the amazing people who've been running them, and doing the little experiments to go along with them. Happy 20th anniversary, GETT!
Hi, my name's Al. I'm a science interpreter at the Franklin Institute, and I'm here to bring you this week's edition of Spark of Science. Do you recognize the sound? Listen closely. That's the sound of a human heartbeat. Scientists and physicians have observed the sound, function, and anatomy of the human heart for centuries in an attempt to better understand our own bodies. But did you know that this research is not confined to here on Earth? The International Space Station, which orbits around our planet at about 250 miles above the Earth's surface, is a science lab. Researchers from around the world conduct tests on all sorts of science topics. They even perform experiments on themselves. Since 2007, NASA has conducted a program called the Cardiovascular and Cerebrovascular Control on Return from ISS. This specific test examines the effects of long-term exposure to small amounts of gravity. They want to learn how this can affect an astronaut's heart rate, blood flow, and other physical changes that might occur, and how those changes can affect the astronaut once they return here to Earth. One of the most straightforward ways to study the human heart is to listen to a heartbeat. You can even listen to your own. Here on Earth and in the ISS, a tool called a stethoscope can be used to amplify the sound or to make it louder. You may recognize this if you've ever seen it at a doctor's office. Have you ever heard your own heartbeat? By creating an easy at-home stethoscope, you can start making your own observations. Let me show you how.
Here's what you'll need: a funnel, a balloon, some scissors, and a piece of plastic tubing. These can be found at the hardware store. There are many different sizes, and you may need to have a grown-up pick out the right size to fit with your funnel. First, use your scissors to carefully cut your balloon like this. Next, cover the large opening of your funnel with the balloon. Stretching the balloon over the opening will help capture the vibration of your heartbeat. The last step is to connect your funnel to the plastic tube. Now you have a stethoscope.
All right, so here's how to use your stethoscope. First, you want to find a spot with little to no noise interruptions. It'll be easier to hear. Take the balloon side and place it on your chest, slightly to the left. That's where your heart is located. Guide the tube to your ear. Don't stick it inside, but put it right at the opening so you can hear. Now be quiet and listen. So what have we learned about the effect of space on the human body? Well, researchers have found that astronauts experience something called orthostatic hypotension upon return to Earth. To put this more simply, astronauts experience a temporary drop in blood pressure. This occurs because their bodies get used to living in low gravity at the International Space Station. As they get closer to Earth, gravity begins to pull on their bodies, including their blood. Pulls the blood down from their bodies, down from their heads, causing less blood to be pumping near the brain. This is what causes dizziness. Now, you may have even felt this before on the small scale if you've ever stood up too quickly before getting a little bit dizzy. Thanks for joining me for this edition of Spark of Science at Home. I hope to see you all again soon at the Franklin Institute, maybe even around the giant heart. Bye-bye now.
Have your friends ever showed you a picture of their adorable little baby in an ultrasound and it just looks strange? Well, I'm going to show you exactly how to read this. Hi, I'm Brittany Wickham and I'm a science interpreter here at the Franklin Institute. Today, I'm going to show you one of the unique things that you can do here as a visitor. We have an ultrasound machine and I'm going to show you exactly how to read this. With an ultrasound, there's a high frequency sound that bounces off of parts of your body and tells your doctors how thick or thin an object in your body is. So let's start by looking inside of our arm. When we wiggle our fingers, those are actually attached to long muscle bands. So I'm going to use the transducer and a little bit of jelly, and our Medical jelly here is used to get rid of any air gaps and to help us see our image nice and clearly. Now we can see stripes here. The darker colors are fluids, so that's most likely my blood. And the lighter colors are muscles and bones. Watch as I move my fingers here. I'm moving my pointer finger and you can see one band of muscle or one stripe of white moving. I can move my middle finger, my ring finger, and my pinky, and we can see that they're all connected to little bands of muscles. So this is one thing we can use ultrasounds for. Okay, as I'm talking, again, we can see those dark areas, mostly black. Again, that's either gonna be the air inside of my throat or blood. The white areas are the bone and the muscle. You can see my voice box opening and closing as I'm talking. And so when you're looking at an ultrasound of a new baby, first, act like it's adorable. That's what they want you to say. Second, that white area, that's the baby that you're actually looking at. So if you'd like to see your arm or vocal cords at the Franklin Institute, swing by the giant heart exhibit. My name is Brittany. Thanks for tuning in for Spark of Science.
Take a look at some of my crystals. They come in all shapes and sizes and colors, and some even sparkle. Today, we're gonna make our own. Hi, my name's Al, and I'm a science interpreter here at the Franklin Institute. For scientists, crystals has a special meaning. The thing that makes crystals special is that their atoms connect together in geometric organized patterns, creating the shapes that we can see right here. For today's experiment, you're going to need a jar or cup, preferably one that you don't use for eating or drinking. You're going to need hot water, powdered borax, and something to crystallize, like pipe cleaners, feathers, or even a seashell. Today, I've made the letter A out of pipe cleaners for my name. With adult supervision, you can take about 1.5 cups of your hot water and put it into your container. Now, add about 3 to 4 tablespoons of your powdered borax. You want to keep stirring until the powder is no longer seen on the bottom. Borax, the powder we're using in this experiment, is often used for laundry, but for this, it's our source of something called sodium borate. Sodium borate is a crystal. When we add it to our hot water, we create a suspension, meaning those sodium borate particles are spread throughout the water. Now, we have to give it something to crystallize. I'm going to take my pipe cleaner A and wrap it around this stick. I've added an extra piece of pipe cleaner so that it can hang down within our suspension. When we create a suspension like this, all those particles are spread throughout the water. And as it cools down, the water will actually push those particles out of the way, and they'll need a place to settle. We call those places that they settle and form crystals nucleation sites. And with something fuzzy like a pipe cleaner, we give it plenty of places to crystallize. In about 24 hours, you're going to see your crystals form. What do you notice? That pipe cleaner gave our sodium borate lots of nucleation sites to form our crystals. And this isn't the only thing you can make. Spell your friend's name, like Benjamin Franklin. A lightning bolt, a seashell. As a quick safety note, powdered borax can be harmful if inhaled. So do as I did in this video, pour the hot water first and then add your borax. Once your crystals are made, be sure to keep them out of reach of small children or animals, because they may look like rock candy, but they're not edible. So you want to be safe, just like with all other science activities. If you try this activity at home, be sure to share your crystals with us by tagging us on social media. And maybe I'll see you the next time you join us here at the Franklin Institute. Thanks again for joining us for Spark of Science.